This question says, let A, B, C, D be a square and X a point such that A and X are on opposite sides of CD. The lines AX and BX intersect CD in Y and Z respectively. If the area of ABCD is 1 and the area of XYZ is there, determine the length of YZ. Okay, so let me just quickly construct what I understand here. Okay, the question says we have a square like this and we have a point X. So if this is AB, if this is A and that's B, so this will be C, that will be D. We say point X is opposite CD such that A and X are on opposite sides. So X should be a point there. Okay, because A and X should be on opposite side of CD. So A is on this side of CD, X will be on the other side of CD. So this will be point X. Okay, so let's just add two straight lines there. So we have this one here and we have that one there, right? And then it says the line AX and BX intersect at Y, so Y will be a point here and Z will be a point here. Okay, and area of ABCD is 1 and the area of that XYZ is 2/3. Determine the length of Y. So I'm going to call the length that we are required to find is this one here. Let's just call it P for now. Okay, so let's look at this now. Let's construct a perpendicular height here, call it H, and another perpendicular height there, but we know already this one will be equals to 1. Now it's important that you remember the theorem we just did in the previous example. So triangle X or YXZ is similar to triangle AXB. Okay, so you know because this is parallel to that, so it makes these two triangles similar. Okay, now the first thing we know is that triangle AXB is similar to triangle YXZ. Okay, and the other thing that we know is that the area of triangle XYZ is equals to 2/3. That's the next piece of information that we know. So now, since we know that half P multiplied by H is equals to 2/3, then we know that PH will be equals to 4/3. Okay, I'll call this my equation 1. Okay, and then let's remember our theorem, which states that the area of triangle AXB divided by area of triangle YXZ will be equals to, so we need side P, which is corresponding to AB, so this will be equals to AB divided by P squared. Okay, now AXB here, the area of AXB AXB, here the base is 1 and the perpendicular height is 1 plus h. Okay, base is 1, perpendicular height is 1 plus h. So let's write that down. Now this is half multiplied by 1 multiplied by a perpendicular height of 1 plus h divided by area of y xz we already have here as 2 over 3. So that is divided by 2 over 3. Now this is equals to AB, we know it's 1 divided by p squared. Now we have two unknowns. We have h and we have p, but p is the one that we are looking for. So we might want to manipulate this equation here so that we make h subject of the formula. Okay, so if we make h subject of the formula, h will be equals to 4 divided by 3p. So we will substitute that for h. So we get half multiplied by 1 plus 4 over 3p. Let's just say multiply by 3 over 2 is equals to 1 over p squared. Okay, so now we can calculate p. Now 1 over 2 times 3 over 2, it will be 3 over 4. Just take this step by step. Sometimes you make mistakes rushing this. 4 over 3p is equals to 1 over p squared. Okay, so if we multiply everything by 4, we get 3 into 1 plus 4 over 3p. And this is equals to 4 over p squared. Distribute the 3, we get 3 plus 4 over p is equals to 4 over p squared. Multiply everything by p squared, then we get 3p squared plus 4p minus 4 is equals to 0. Okay, now we have a quadratic equation. Can it factorize? Yes, it can factorize, and this will factorize into 3p minus 2 and p plus 2 is equals to 0. So p will be equals to 2 over 3, or p is equals to negative 2, but p is a length, so it can't be negative, so this answer is invalid. Now here's our answer, our p, which is line what? Line YZ, which is our p, is equals to 2 over 3. Okay, so once again, we've proved this principle to be very important and very effective. Of course, there are other ways of solving these questions. However, if you saw that the two were similar, so if you're given two similar triangles and you're given the area of the one, always remember to go for this principle. This question says in triangle ABC, angle A is equals to 45 degrees, angle B is equals to 30 degrees. D and E are points on AB and EC respectively, such that angle EDA is 60 degrees and ED divides ABC in two parts of equal area. And we are required to find the ratio of side AD divided by DB. Now let's just quickly draw the sketch. So here's our sketch. We drew ABC here, and they told us E lies on AC and D lies on AB. Now they say that angle B is 30 degrees and triangle A is 45. Let's just write those. And angle EDA is 60 degrees. So because of sum of angles in a triangle, it automatically makes this angle here 75 and this angle here 105. So just like any ratio questions, we will assume AB to be equal to 1. So when you deal with ratio questions, you can always say something is equals to 1 because ratios always simplify to their simplest form. So the whole side here is 1, and we will assume AD to be x, so that will be x, and this is just 1 minus x. I will also say this side ED is A and BC is B because of calculation purposes. Okay, now we are actually required to find AD over DB, which is x divided by 1 minus x according to our sketch here. And we are also being told that the area of triangle ADE is actually half of the area of the big triangle, area of the triangle ABC. Okay, so area of ADE is half A multiplied by x multiplied by the angle between them, which is sine 60, and this is equals to half of AB, which is 1, multiplied by B multiplied by sine of the angle between them, which is 30. Okay, so let's try to simplify this further. Now sine 60 is root 3 over 2 multiplied by half, so we would have A multiplied by x multiplied by root 3 over 4, and this will be equals to B multiplied by half times half. Sine 30 is half, so that will be 1 over 8. Okay, so if we make x the subject of the formula, here we get x is equal to multiply by 4, so that will be 4b divided by a multiplied by 8 root 3. Okay, so this can also simplify because 4 goes into 4 once, goes into 8 twice. This can simplify into b divided by 2a root 3, which we can also write it as a set a into root 12. So I'm going to call this equation 1. Okay, now let's apply the sine rule to this sketch. Let's start with ADE. So in triangle ADE, we can see that we have x over sine of 75 and a over sine of 45. So we have a divided by sine of 45 equals to x divided by sine of 75. Okay, I'll call this my equation 3. Not 3, sorry, equation 2. And then in triangle ABC, apply the sine rule there. So it's going to be 1 over sine of 105 and then b over sine 45. Okay, so we have b over sine of 45 is equals to 1 over sine of 105. Okay, so usually when I see a trig ratio of an obtuse angle, I always want to reduce it, makes things easier. So sine of 105 is the same as sine of 75. And I'm going to say that's my equation 3. Okay, now the next thing that I'm going to do is to divide equation 2. So equation 2 divided by equation 3. So, and I immediately get a over b is equals to x. Okay, so I have two solutions for x. I have a over b, which I'm going to call this equation 4. So let's say that's equation 4. And then the next step, because I can see in equation 1 I have x is equals to something, and equation 4 I have x is equal to something, and I have a over b on equation 4, I have b over a on equation 1. So I will multiply. So I will take equation 1 and I will multiply it by equation 4. Okay, so I will get x times x, which is x squared. A over b with cancel with b over a, and I have 1 over square root of 12. And this will simplify into x is equal to 1 over the 4th root of 12. Okay, if you take the square root of a square root, you have the 4th root. Okay, now, because I'm required to find x divided by 1 over x, instead I will choose to go and find 1 minus x over x. Okay, because it will make my calculation simple, because I can simplify this to 1 over x minus 1. So this will be equal to, so 1 over x is the reciprocal of what we have here, which will be the 4th root of 12 minus 1. Okay, and therefore, this becomes easier now, and therefore, x over 1 over x will be the reciprocal of what I have here, which will just be equal to 1 over the 4th root of 12 minus 1 as our answer. This question says point A and B divide the quarter circle arc CD into 3 equal parts. From A and B perpendicular, A and A prime and B prime are dropped to OD. If the radius of the quarter circle is 1, what is the area of trapezium AB, B prime and A prime? Okay, so what we're looking for here is the area of this trapezium here. Okay, so now we know that OA and OB are both radii. So OA is equals to OB and both equals to 1. Okay, and since the quarter circle is divided into 3 equal parts, that means this is 30 degrees, that's 30 degrees, and that is also 30 degrees. Okay, now I'll use trig as I think it's easier for you to understand. Now, in triangle OAA prime, right, sine of 60, remember this angle here is 60, this is the triangle we are talking about, OAA prime. So the angle here is 60, the opposite is AA prime, right? So sine of 60 will be equals to AA prime divided by OA, but we know that OA is 1 already. So AA prime would be equal to just sine 60, which is root 3 over 2, and cos of 60 would be equals to OA prime divided by OA. And we know that OA is 1, that means OA prime is equals to 1 over 2. Okay, so we do the same thing with triangle OB, B prime. Okay, so sine 30 will be equals to B prime divided by OB. We know that OB is 1, so B prime is equals to 1 over 2. And cos of 30 will be equals to OB prime over OB. OB is 1, so OB prime would be equals to root 3 over 2. Okay, and then, so we have this side of the trapezium, and we have this side, and we have this OB prime and OA prime. And remember, we need A prime, B prime, which will be equals to OB prime minus OA prime, and that will be equal to OB prime is root 3 over 2 minus OA prime 1 over 2. So this is just root 3 minus 1 all over 2. Now we can plug in all the information we have, because the area of that trapezium would be equals to half A prime plus B prime. Those are the opposite, parallel opposite sides, A prime and B prime, and the perpendicular height is what we found here, right? A prime, B prime. Okay, so that is multiplied by A prime, B prime. So this will be equals to half A prime is root 3 over 2 plus B prime is 1 over 2, and that is multiplied by root 3 minus 1 over 2. Okay, so what we see here is just the difference of squares, simplifying to 3 over 4 minus 1 over 4, and this is equals to 1 over 2 multiplied by 2 over 4, so half multiplied by half, and the area is just 1 over 4. Okay, you could have also realized that the two triangle OA prime and OB prime are actually congruent, okay, because they have the same hypotenuse, which is 1, same 90-degree angle there, and this one has 60 here, that automatically makes that angle there 30. This one has 30 there, automatically makes that angle 60. Okay. Question says D is a point on side AB of a triangle ABC. E is a point on CD and F is a point on CE. The areas of triangles AED, AEC, BFD and BFC are 6, 10, 17 and 7 respectively. What is the area of triangle BEF? Okay, now the principle that we are required to use here is that if I have a triangle, this is an important principle and you must remember, and I divide it like that. Let me call this A, B, C, D. Okay, so it's important to note that there is only one perpendicular height for all these triangles. Okay, so they share the same perpendicular height. Now, the area of ABC divided by the area of ACD, this will be equals to, so for ABC, it will be half the base is BC and the perpendicular height of H divided by half the base there is CD, perpendicular height of H. Now what happens is the half cancels the half, h cancels the h, and we can see that if we divide two areas that share the same perpendicular height, we end up having the ratio of the bases. Okay, so this is the principle that we are going to use. Now, let's apply this to this triangle here. Okay, so we are required to find the area of BEF. So let me just construct a line here. So we are required to find BEF. So first of all, we can see that ADE and DBE, they share the same height. Okay, so we are going to use that. So we are going to need the ratio of their bases. Okay, so but the whole triangle is going to help us do that. Now, the area of triangle ACD divided by area of triangle DBC will be equals to, so that's 6 plus 10 for ACD, it's just this one, ACD. It's only 6 and 10 for this one is going to be 17 plus 7. So this is divided by 17 plus 7, and we get 16 over 24, which can further be simplified into 2 over 3. Okay, because 8 goes into here 2 times, goes into 24 3 times, yes. Now, what do we know? This is equals to the bases. This is actually equals to AD divided by BD. Okay, because this were the base. They share the same perpendicular height. So AD over BD or DB, it will also be 2 over 3. And then from here, we can start concentrating on these two triangles because we have the ratio of the bases. And then area of ADE divided by area of DBE will be equals to 2 over 3. Okay, and then we know the area of ADE is 6, so 6 divided by area of DBE will be equals to 2 over 3, and therefore the area of DBE will be equals to 6 multiplied by 3 over 2, which will give us an answer of 9. Okay, but that's for DBE, but the question wants BEF. Okay, but we know that if the whole thing is 17 and we know this one is 9, we just need to subtract. Okay, so therefore area of BEF will be equals to 17 minus 9, which will be equals to 8. Very, very important principle to learn this one, okay? So if we have two triangles that share the same perpendicular height, then the ratio of their areas is the same as the ratio of their bases. Okay, so that brings us to the end of our session. Thank you for listening, ladies and gentlemen, and have a good time.